right, for the next example, we're going to be looking at example 3, which is a little bit trickier because you have a triangle that you're looking for the area of, and the problem is that it is rotated a little bit in the coordinate plane so that you don't have a straight line horizontally or vertically anywhere. And remember, the base and the height have to be perpendicular to each other. So the first thing I need to think about is my slopes. So my slope for BC is down 1, 2, 3, 4, 5, 6, right 1. So M for BC is down 6, right 1. So negative 6. Okay? It's my rise over run. Now for AC, it's down 2, right 1, 2, 3, 4. So that would be negative 1/2. And for AB, it is up 1, 2, 3, 4, right 1, 2, 3, so 4/3. Now, the reason that's important is because that tells you right there that we don't have any negative reciprocals in our slopes, so we don't have a 90-degree angle anymore. If we had a 90, that would be perfectly perpendicular. You can use one of those as the base, the other one as the height. But we don't have that, so we can't do that. So we got to do a lot more work with this. All right. So this is probably going to be a 2-part video, by the way we're going. So here we go. We're going to make AC be our base, which means I need a line that is perpendicular to that line coming from B. So the first thing I need to do is figure out what my equation is for AC. So again, we already had the slope for AC was negative 1/2. So if we do our point slope formula, pick a point on that line, so 1, negative 1. So it is y minus y1, which is negative 1, equals slope, which is negative 1/2, times x minus 1, because it's positive 1. All right, so we get y plus 1 equals negative 1/2 x plus 1/2. And then if we subtract 1 from that, we end up with y equals negative 1/2 x minus 1/2. Great. So my slope for my other line ought to be, and I'm going to go over here to do it, I ought to have a slope of positive 2 because it's got to be perpendicular. So we have y minus, and I'm going to use this point up here, b, for the next part. So y minus 3 equals 2 times x minus 4. Okay? And so now I'm going to clean this up. Y minus 3 equals 2x minus 8. Okay? And so then I get y equals 2x minus 5. Okay? Now, let me bring this one back over here. Y equals negative 1/2 x minus 1/2. Those are perpendicular. My next issue is I don't know where they intersect at. Okay, so I'm going to use that though. So it's up 2, right 1. So here, down 2, right 1 here, down 2, right 1 here. So we're talking about this line right here. So the problem I have now is I don't know where that is. Okay, it's not a very nice point. So how can I figure it out? Well, it's where these two things intersect. So 2x minus 5 equals negative 1/2 x minus 1/2. All right. So we're going to add and subtract. Here we get 1 and 1/2 x. I'm sorry, no, 2 and 1/2 x, my bad, equals, and then over here we've got add 5 to both sides, that'd be 4 and 1/2. So now I need to divide 4 and 1/2. Let's clean this up, make it a little easier. 5 over 2x equals, that would be 9 over 2. So I need to multiply by 2/5. So x is going to equal 9/5 because I did 2 over 5 and 2 over 5. Now let's move with 9 over 5. All right, now, why is that beneficial? How does that help me? Because I now know this point where we intersect. I can now find the distance between those, okay? Because I can find my y value to go with this. So if I plug it back in to my equation, 2 times 9/5 minus 5. Okay, I get a y value of -7/5. So here's what I need to do now. I need to use my points to find the distance that would be the height. And then I have to calculate the distance for the base and go from there. So I'm going to do that in the next video because I'm sure I'm running short on time. Okay?